Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC U1101, specifically signifies a fan malfunction associated with the Powertrain Control Module, PCM, and the Active Control Module, ACM. This malfunction indicates that there might be communication issues between these critical electronic control units. The PCM primarily governs the engine and transmission functions, ensuring optimal performance and efficiency of the vehicle. In contrast, the ACM regulates functions related to the vehicle's active systems, such as steering and suspension. These components are typically located in the engine bay. The PCM is mounted on the driver's side, while the ACM is situated near the engine control wiring harness. Proper communication between these units is crucial for the proper functioning of numerous vehicle systems, making it essential to investigate any related issues thoroughly. DTC U1101 highlights an issue within the FCAN, or the Faulty Controller Area Network, which serves as a communication pathway for data transfer between various electronic modules, such as the PCM and the ACM. The PCM, serving as a command center for engine functionalities, is responsible for adjusting parameters for optimal engine performance and emissions management. The ACM, on the other hand, handles active control features which enhance ride comfort and vehicle handling. Usually, issues arise from poor wiring connections or faults in the internal electronic components of these modules. Both modules are located in the engine bay. Specifically, the PCM is generally mounted to the driver's side fender well, while the ACM is located near the power distribution center. Accurate troubleshooting of DTC U1101 is vital as it can assist in resolving underlying operational issues in the vehicle. When diagnosing DTC U1101, several potential causes need to be considered. Firstly, poor connections can arise from corrosion or damage to the wiring harness, impeding effective communication between the PCM and ACM. Loose terminals at key connectors can also lead to intermittent failure, thus creating inconsistencies in signal transmission. Another possible cause is malfunctioning or faulty control units themselves, which may require inspection or replacement. This code often requires a methodical approach to determine whether the disconnection is a result of wiring, terminal issues, or internal circuitry problems within the control units. Understanding these possible causes will aid technicians in formulating an efficient and effective troubleshooting strategy. The manifestation of DTC U1101 can present several operational symptoms to the driver, focused primarily on the electronically controlled components. A common sign would be the illumination of the malfunction indicator lamp, MIL, on the dashboard. This alert serves as an initial indication that the vehicle's electronic systems are not functioning as intended. Additionally, drivers may experience poor engine performance characterized by irregular acceleration, stalling, or reduced fuel efficiency due to compromised PCM operations. The transmission may also exhibit shifting difficulties or erratic behavior, as both systems are inherently interconnected. Recognizing these symptoms can expedite diagnostic procedures and ensure swift resolution to maintain optimal vehicle performance. The initial troubleshooting step involves turning the ignition switch to the on position, also known by its designation as 2. This action powers up the vehicle's electronics without starting the engine and allows access to onboard diagnostics. It is crucial at this point to document all freeze frame data and any onboard snapshots captured by the vehicle's engine control unit, ECU. This information assists in understanding the conditions under which the DTC was triggered. Following this, it is imperative to review the general troubleshooting information for insights into specific diagnostic procedures associated with the DTC U1101. This foundational step ensures that all subsequent troubleshooting actions are based on solid data and context. In this step, the next logical action is to clear the diagnostic trouble code using the Honda Diagnostic System, HDS. HDS is a specialized tool used for vehicle diagnostics and has capabilities that allow technicians to reset codes and clear fault memory stored in the ECM. Clearing the DTC ensures that any transient faults are eliminated from the ECU's memory, allowing the technician to assess whether the issue persists. If the problem recurs after clearing, it signifies a deeper, likely persistent malfunction within the FCAN system. Thus, utilizing the HDS is critical for accurately resolving DTC U1101 by confirming whether it is a permanent or intermittent issue. Following the clearing of DTCs, the next procedure involves checking for any pending or confirmed DTCs via the HDS. Pending DTCs signify that the fault is not currently active, but was detected previously under certain conditions. Confirmed DTCs indicate that the issue is actively affecting vehicle systems. If DTC U1101 is indicated during this check, it verifies that the FCAN malfunction persists, warranting further investigation. Conversely, if no issues are confirmed, it may reflect an intermittent fault in the system, suggesting that the circuit connections may need inspection for poor contact or loose terminals. Recognizing the difference between the two will inform the technician on how to proceed effectively. In this step, it is essential to check for any active control module, ACM system-related DTCs, through the DTC menu on the HDS. The ACM is responsible for managing functionalities that affect the vehicle's handling and ride quality, and any faults here can manifest in performance issues. Determining whether DTC P15AB or any other ACM-related codes appear is crucial. If DTC P15AB is indicated, the technician will need to address related troubleshooting for that code specifically, as it may offer clues that contribute to the U1101 malfunction. If no ACM system DTCs are present, the technician can then move on to the next troubleshooting step, indicating that the ACM may not be the root cause of the U1101. At this stage, turn the ignition switch to the lock position, which effectively powers down the vehicle's electrical system safely. This step is crucial for ensuring the technician's safety while handling electrical connections and performing the next tests. It also prevents any accidental shorts or erroneous signals from affecting the diagnostic process. Once locked, the technician should be prepared for further examinations of the electrical connectors associated with both the PCM and the engine mount control unit. Ensuring proper handling during these actions is key, as they make way for effective continuity tests that will ultimately determine the integrity of the connections involved with the malfunction. The following step entails jumping the SCS line with the HDS. The SCS, or the Security Command System, is utilized during troubleshooting to bypass the vehicle's security features temporarily, allowing for comprehensive diagnostics without triggering alarms or other security-related interruptions. This action prepares the system for checking connections and facilitates a straightforward process for disconnecting the engine mount control unit. The technician must be vigilant while executing this step, ensuring that the HDS properly interfaces with the vehicle's systems without causing any additional faults. Successfully completing this step enables further necessary testing of the affected control units. In this troubleshooting step, the technician will disconnect the engine mount control unit by removing the 16P connector associated with it. The engine mount control unit is pivotal in managing the engine's vibration and its relationship to the vehicle's suspension stability. Taking this connection apart is essential to gain access for further continuity tests and inspection of terminal integrity. The technician should handle the connector delicately, ensuring not to damage any terminals while disconnecting. Attention to detail during this step is critical, as any signs of corrosion or damage may indicate previous issues that could relate to the DTC U1101. Next, disconnect the PCM connector A, which has a total of 49 pins, facilitating the next phase of the diagnostic process. The PCM is a key player in receiving and transmitting data within the FCAN system, meaning that correct functioning is pivotal. The disconnecting task permits the technician to perform continuity checks between various terminal connections within the circuitry. Proper handling of the PCM connector is essential to prevent any damage, which could lead to further complications down the line. Clearing the connections at this junction unlocks the possibility of quickly identifying any wiring faults or continuity issues between the modules involved in the U1101 code. In this step, the technician will check for continuity between PCM connector terminal A48 and engine mount control unit connector terminal number 14. This action is vital for verifying the integrity of the CAN-H signal, which is responsible for data transmission from the PCM to the engine mount control unit. A continuous circuit between these terminals confirms the reliability of this communication path. If continuity is confirmed, it suggests that there are no breaks or faults in the wiring as far as these particular connections are concerned, allowing the technician to continue troubleshooting further. Conversely, if no continuity is detected, it indicates an open circuit, which will require the technician to trace the wire between the PCM and the engine mount control unit for repairs or reconnections. Next, continuity checks are performed between PCM connector terminal A49 and the engine mount control unit 16P connector terminal number 12. This test is critical for verifying the functionality of the CAN-L signal, which plays a complementary role to the CAN-H in data transmission. Confirming continuity here ensures that the communication link remains intact and operational between the two components. If the connection is present, it indicates no circuit interruptions, supporting the hypothesis that the FCAN architecture is functioning correctly at this junction. However, if no continuity is identified, this may point to another technician intervention area, necessitating further inspection of the wiring and connections that may be faulty or damaged. Once repair actions related to DTC U1101 are completed, it is essential to conduct a thorough operational integrity test. This testing involves driving the vehicle under various conditions to ensure that both the PCM and ACM are functioning correctly and that all previous symptoms have been remedied. It's critical to look for any recurrence of the DTC as well, utilizing the HDS once more to confirm no lingering codes will provide reassurance that the earlier communication issues are fully resolved. The integrity of connections and components must be ensured to avoid future operational disruptions. Following this repair verification process will help to validate the success of the troubleshooting efforts undertaken. To reduce the risk of encountering DTC U1101 in the future, preventive maintenance is essential. One effective strategy is to regularly check and clean the connectors associated with the PCM and ACM, ensuring they are free from corrosion and securely fastened. Preventative checks on the wiring integrity throughout the vehicle, particularly in high-motion areas like the engine bay, will help in avoiding insulation damage or wear and tear caused by vibrations. In addition, using protective coverings for exposed wiring can also extend the lifespan of these components. Education on recognizing the early warning signs of electronic issues and using proper diagnostic techniques can maintain optimal vehicle performance. By employing these practices, potential communication failures in the FCAN can be preemptively addressed. To summarize, DTC U1101 reflects a critical malfunction in the FCAN communication between the PCM and ACM, necessitating careful and systematic troubleshooting. Understanding the roles of both the PCM and ACM within the vehicle's ecosystem provides insight into the importance of their proper functioning. Early identification and resolution of symptoms, such as engine performance issues or warning lights, can streamline the diagnostic process and reduce costs. By following the prescribed troubleshooting steps, technicians can systematically verify connections and ensure robust communication lines between the modules. Conducting repairs based on the established protocols ensures that the vehicle operates correctly across all systems. Adopting preventive maintenance strategies will mitigate the risk of DTC U1101 recurrence and enhance the longevity and reliability of the Honda Accord. Please like and subscribe to the channel. See you next time!